Welcome to my channel. I'm playing with some old stuff again. This time a Swiss-made Revox stereo amplifier. It's the model Revox 40. It's one of their first stereo amplifiers, still with vacuum tubes inside. And yeah, let's see what it can do. What we can do with it. Let's measure if it still has its 2 times 10 watts, which is, by the way, plenty for a medium-sized room. You seldom use more than 5 watts or even less. And yeah, let's clean it up and have a look inside. And as always, first turn it on, then take it apart. I have my MP3 player here connected. Takes a moment to heat up. Okay, so far sounds pretty nice. All the controls are working, no crackling on the pots. There is a slight hum, so I think this amplifier will probably need some new capacitors, at least the main filter capacitors for the power supply. Otherwise, they have these foil capacitors here. They almost never go bad. I have to clean the keys a little bit here, the buttons. Alright, everything here in its beauty. We have the first 2 tubes here. They are for the phono amplifier. It has a 1 phono input here for a record player. Then the next 2 tubes are the normal preamplifier for all the inputs. They are switched here with the buttons, and they all go to this second preamplifier. And then we have a preamplifier and a end tube, a power tube. It's the same model here. We have 4 times the same. What is it? ECL 86. They don't have a left and a right channel, they have a channel 1 and a channel 2. Doesn't matter, as long as everything is labeled, no problem. Here we have the mains transformer that converts our 240 volts, 230 volts to 300, 250, 235, 170 volts for all the tubes. And here we have 2 output transformers, each one for each channel. We will see that a little bit later, because I have to check if the amplifier is wired for 4, 8 or 16 ohm speakers. You have to solder and change some wires here accordingly to the speakers you have. Let's have a look at that. Well, here we have the output transformers for the left and right channel. I don't know which one is which, but that doesn't matter. They are identical. We have one wire going from here to here and the same on the second transformer. That could be 16 or 4 ohms. The 8 ohm version has that wire in a different place. But we also have these two loops here, and that means we are wired for 4 ohm. Now what I want to do is to rewire that to 8 ohm speakers, because that's the most common value and that's most of the speakers I have are 8 ohm. So let's go for that. Here we have the schematic diagram of the output transformers. Just to see what I'm doing next. On the top we have the circuit for 16 ohm speakers. You can see the two output coils, the secondary windings. They are connected in series. The lower coil is connected to ground, then through that X-shaped circuit to the upper coil, and then the hot wire goes to the speaker. Below we have the circuit for 4 ohms at the bottom, not that one in the center. You can see the two output coils, the secondary windings, are connected in parallel this time. You see the ground connector goes to the lower part of the lower coil and also to the lower part of the upper coil, and both the hot wires are connected together parallel. That's for 4 ohm, and what we need, or what I need, is 8 ohms. And you can also see the two output windings are connected in series again. But the output, the hot wire, is connected to the center tap of the upper coil. So that gives then an impedance of 8 ohm. Well, it seems it still works. Is it louder than before? Maybe. Another interesting detail is that the treble and the bass regulators switches are switches and not potentiometers. And when you look down here, you can see that even the switches were made by Revox, so they didn't take any from the shelf components. They made their own together with the PCB. Yeah. And by the way, the switches are labeled with decibels. We have 4, 8 and 12 decibels, and I'm pretty sure this is bang on exactly. Here we have 10 kilohertz, decibels at 10 kilohertz, and the bass is measured at 50 hertz. So I'm sure if you connect that to your oscilloscope or power meter, 4 decibels, 8 or 12, that's exactly what you get. The tone control on this amplifier is pretty amazing. If you look at V3 ECC81, the left part of the tube, there are two outputs, one above the tube with this little capacitor and one below the tube across the resistors. These two outputs are 180 degrees phase shifted. So I call the upper output the direct line, and the lower output I will call the inverted line. Now the inverted line goes to the treble switch, the moving part, you can see that. And the direct connection, the direct line goes to the bass switch, to this connected ring that connects to both switches. So the bass switch is a double rotating switch, so they're coupled together. And the way it works, as far as I understand it, is they mix a negative signal to the positive signal, and the amount of the negative signal depends on the capacitors. If we look at the treble switch, for example, if we switch one position up, we have a relatively small capacitor, so the original signal gets mixed with only a little bit of the negative signal, so that will reduce the treble. Only the high frequencies pass that capacitors. It does nothing to the low frequencies. And if we switch 2 steps further counterclockwise, we connect to a larger capacitors, so more of the negative treble will added to the original signal, so we have less high frequencies. And a similar principle is for the bass. They are also adding some negative, also phase wise negative signals to the original signal, and that will lower or increase the bass signal, the low frequencies. And then the whole thing goes over to another capacitors and then to the balance potentiometers and finally to the power stage, the amplifier. I think that's a pretty interesting concept with mixing positive and negative phase signals together, instead of just having an RC filter like most amplifiers or radios would have. Well then, let's clean the buttons. I wonder how they work. No, that's not the type with the cap. So we simply pull them off. They even have a metal spring inside to grip tightly to that shaft. Okay, it's 4 times the same button, so we don't have to care which one goes where. And for the push buttons, it's the same principle. I already cleaned 2 of them, so there's no need to remove them. They go on really hard and you have to pull pretty hard, but it works. They also have a spring, a leaf spring inside. I show you how that works in a moment. Okay. So first of all, you have this weird cross shape here. That means the switch can be mounted vertically or horizontally, so you only need one model of switch for all the devices you have. That's pretty clever. And the leaf spring is just laid inside here. You can see it has a flat side here that goes in like that. And the spring is under this metal tab here, so you have to be careful not to lose that, and also to install it the right way, because if you install it on top of the tab there, the switch will be in the wrong position and it will stick out too high or too low. Let me see, too low, yes. So that is something you have to remember. Okay, let's clean it. It seems the spring inside the round buttons comes off as easily as the other one, so I better remove that before I clean them. While I was playing with the speakers connectors here, I noticed that the connectors for channel 1 are a little bit loose, so I can correct that. You can also see it, they're a little bit bent here, bent apart, so maybe someone stumbled upon the speaker cable. Okay, but that's pretty easy to fix. Yes, nice, much better here. Okay, next problem. Next problem is this edge here on the back panel. Nothing big, but someone smeared some paint on it. Well, it looks like paint because I already tried alcohol, isopropyl, but that didn't do the job, and so I got paint thinner, and that seems to remove it. The good thing is that the panel here is anodized aluminium, so this paint won't go off with any solvents, because that's not paint, it's etched into the aluminium. Okay, that looks already much better. Not that anyone would actually see that especially when the cover is on, but yeah, I think if you can, then you should. Yeah, it seems it's still working, so let's try and measure it, how much output power it still has. Well, then everything is connected, dummy load is connected, frequency generator, let's crank it up, remove that sound. And we can go to that much. You can see it starts to limit on the top, not on the bottom. Now in the middle also. So we go to about that level. Let's allow a little bit of distortion, and we have 6.97, well, let's say 7 volt effective voltage, 7 volts, that's 6.1 watts. Okay, we should have 10 watts, we don't get that. Well, why not? Maybe it was 10 watts on 4 ohm, I don't know how they measured that. And here you can see the back side of the capacitors. There are 3 capacitors. Each one has 3 separate capacitors inside. On one capacitors they are all connected together in parallel. The others have resistors between, so they effectively make different voltages like that. And I think I leave the capacitors in because the hum has already reduced, and yeah, sometimes you have to use this stuff and it becomes better. Sometimes not, but I think in this case I don't have to replace the capacitors. Okay, thanks for watching. That's all for today.